Another reason that traffic might not be flowing over our GRE tunnel is that somewhere along the path we've got the source router, maybe multiple routers in between, and then our destination router. Somewhere along that path there might be an access control list, an ACL, that's blocking GRE traffic. After all, GRE, it's its own protocol. It's protocol number 47. How do we fix that? Well, we need to go find where that access control list is. We can just start inspecting routers each hop along the way if we suspect that's what's going on, and we can give a statement much like this. We can just add on to whatever access control list is currently existing, something to the effect of what we see on screen. We want to permit the GRE protocol from any source to any destination. One other GRE issue we want to talk about, and that's fragmentation. Normally, an interface has its MTU size set to 1,500 bytes. And if we have a packet coming in that's larger than that, we typically call that a giant. Actually, 1,500 bytes, that's the packet MTU. If it's an Ethernet interface, that's layer 2, that's a frame. Sometimes we say that the MTU is 1518. Well, that's including layer 2. I'm using 1,500 just to talk about the layer 3 packet header. I'm not talking about layer 2 header information. But the interface is normally set to 1,500. Here's the challenge. We've got a header associated with our GRE packets. It's a 24-byte header. And this 24-byte header would exceed that 1,500-byte MTU that we by default have set on our interfaces. And that could force some fragmentation to happen. What do we want to do to prevent that? Well, the recommendation Cisco gives us is every interface hop along the way for our GRE tunnel, let's reduce that default 1,500-byte MTU size, let's reduce that by 24. In other words, let's set it to 1476. That's what we're doing here. Simple command, we just go into interface configuration mode for that virtual tunnel interface, and we want to say that the MTU is 1476. And if we do this end to end and we set that consistently, that's going to help, hopefully it's going to help reduce some unnecessary fragmentation and poor network performance. Oh, and there is one other GRE issue I want to make you aware of. It wasn't formally listed on our introductory slide to GRE. However, it's something you might run into if you're doing IPv6 over an IPv4 network. You might have a couple of routers with IPv4 only running between them, and you want to run IPv6 over that IPv4 portion of the network. Well, a GRE tunnel, that's a great fit. You could have a GRE tunnel, and remember, GRE is going to encapsulate just about any layer 3 protocol, including IPv6. We can just put those IPv6 packets inside of the GRE tunnel and send them over to the other router. However, if we're doing IPv6, there is another option that might have been configured. It's IPv6 over IP. That's one mode of the tunnel that we might configure. With IPv6 over an IP tunnel, what we're doing is taking an IPv6 packet, encapsulating it inside of an IP version 4 packet, and sending it across the tunnel. That is actually going to have less overhead than a GRE packet would have. However, it's not as flexible as GRE. You have to decide what's best in your environment. The point is, both ends of the tunnel need to match. Let me take you out to a live interface and show you a situation where they're not matching. We're sitting here on router R1, and let's do a show interface tunnel 1. And I've got a tunnel right now set up between routers R1 and R2, and I want you to notice that the tunnel protocol right now is GRE/IP. That's what we've been talking about. And if I take a look at the status of the tunnel, if I do a show IP interface brief, look at that. It gives me an indication that the tunnel is up. Fantastic. And I see the IP address. However, if I go over to the other side and do a show interface tunnel 1, the other end of this tunnel, we've got a different protocol type here. Look at this. The tunnel protocol is IPv6/IP. That's a different mode. And it appears that the tunnel's up. If I do a show IP interface brief, the tunnel does appear to be up. It's up at layer 1, it's up at layer 2. However, if I try to ping the far side, let's try to ping 172.16.10.1. That's the IP version 4 address on the other end of this tunnel. It fails. I can also try to ping the IPv6 address that's assigned to the other end of this tunnel. Let's do a ping to, it's 2222::1. That's the far side of this tunnel. And you see it is failing as well. And that's because we have a tunnel mode mismatch. One side is set to GRE over IP, the other side is set to IPv6 over IP. How do we fix that? Well, it's pretty simple. Once we determine that we do have that mode mismatch, we can go into interface tunnel configuration mode for tunnel 1, and we can simply say tunnel mode. Context sensitive help shows us our options. We want to set it to GRE, which is what we're using on the other side, and we're going to say GRE over IP. We're doing IP version 4. Now we should have a successful ping. Can I ping the IPv6 address on the other side of the tunnel? Yes, I can. Can I ping the IP version 4 address? Yes, I can. That was an issue where we had a tunnel mode mismatch.